Welcome to The Explainer. Today, we are taking a deep dive into something called regression analysis. Now, that might sound complicated, but really, it's about turning data from just a bunch of numbers into a powerful prediction machine. We're going from just guessing how things are related to actually forecasting what's coming next. You see relationships like this all the time, right? The more you water a plant, the taller it grows. The more hours you study, the better your grade is. We know there's a connection, a correlation. But what if we want to get specific? What if we want to say, okay, if I study for exactly 5 hours, what grade can I actually expect to get? Can we do that?
Well, that's precisely where regression comes in. It's the difference between knowing two cities are connected by a road and having a GPS that can tell you exactly where you'll end up. Correlation just points out the connection. Regression, on the other hand, builds a tool from that connection, letting you plug in one value to get a specific calculated prediction for the other. It's a whole other level of understanding.
So here's how we're going to break it all down. First, we'll look at what our prediction machine is actually made of. Then, we'll check out the two main designs or blueprints you can use. After that, we got to cover the essential rules, the user manual, if you will. And finally, we'll see how this powerful idea is already working all around you.
All right, let's pop the hood on this thing. At its very core, this prediction machine is actually surprisingly simple.
The absolute heart of regression analysis is this one idea, the line of best fit. Just picture a bunch of data points scattered on a graph. The regression line is one single straight line that slices right through them in a way that best captures the overall trend. Think of it as the main highway through all that messy, scattered data. It's our guide. Now, to make any prediction, we need to know who the main players are. First, you've got the independent variable, which we call X. That's your input, the cause you can measure or even control, like how much sunlight a plant gets. Then you have the dependent variable, or Y. That's the effect, the outcome we're trying to predict, in this case, how tall the plant grows. The entire game is just using X to make a really good guess about Y.
So, let's talk blueprints. Because it turns out there isn't just one type of prediction machine. Nope. Depending on what you want to predict, you'll actually need a slightly different design.
This first one is the one you are going to see like 99% of the time. It's called the Y on X regression, and it's built to do exactly what we've been talking about. Predict the effect, which is Y, based on a cause that you already know, which is X. Now here's the really clever part, how it finds that best fit line. Imagine drawing tiny little vertical lines from each of your data points straight down or up to the prediction line. The Y on X model adjusts its line until the total length of all those little vertical error lines is as small as it can possibly be. It's all about being as accurate as possible for Y. But what if you want to work backwards? What if you find a massive, fully grown plant and you want to guess how many hours of sunlight it must have gotten? See? You know the effect, and you want to try and estimate the cause. For that, you need the second blueprint, X on Y. It totally flips the script. This time, the line is drawn to make the horizontal distances, the side-to-side errors from your data points to the line, as tiny as possible. It's specifically designed to give you the best possible prediction for your X variable. So you have two different goals, which means you get two totally different lines. Okay, so we have our machine and we have our blueprints. But just like any powerful tool, it comes with a user manual. There are a few key rules you have to follow to make sure your predictions are actually logical and, mathematically sound. And these rules just show the tool's built-in common sense. For instance, the signs have to match. If more sunlight leads to more growth, that's a positive relationship, so the line has to slope upwards. You can't have them pointing in opposite directions. There are also mathematical guardrails that keep the numbers in check. And what's really fascinating is that both of those regression lines we talked about are directly mathematically tied back to that original correlation we started with. It's all one big, elegant system. And here is a super simple but really profound rule. The prediction line will always, without fail, pass right through the average point of your data. Think of it like the center of gravity for your whole data set. This makes sure the line is perfectly balanced and truly represents the central trend of all your information. Okay, so that's the theory, but why on earth should you care about any of this? Well, because this prediction machine is running silently in the background of our world every single day, making decisions that affect all of us. Let's look at a couple of examples. Let's kick things off with business. Imagine a company has a marketing budget, and they want to know how many sales they're going to get for their money. This is a total classic regression problem. So what they do is they analyze their past data, where ad spend is the X and sales is the Y. By building a regression model, they can literally turn their budget into a pretty reliable sales forecast. It lets them say, hey, if we spend 100 grand on ads, we can expect to bring in around 400 grand in sales. That is a seriously powerful tool for making smart business decisions.
Now for something a lot less corporate, but incredibly important. In medicine, doctors can use regression to help estimate patient outcomes, which helps them personalize care for each individual. By looking at how things like a patient's age, the dosage of a certain medicine, and their prior health have related to recovery times in the past, a regression model can help predict how long a new patient might take to get better. This isn't about telling the future, it's about using data to manage expectations and to tailor a treatment plan that's just right for that person.
And that's really the amazing thing here. Everything we've talked about, from business forecasts to medical outcomes, it all boils down to the relationship between just two variables. You start with a cause and an effect, an input and an output. And from that one simple pairing, regression analysis builds a bridge that lets you step from what you already know into what you can reasonably predict. So, here's the big takeaway. Regression is way more than just a formula and a statistics textbook. It's a fundamental tool for making sense of the world. It's the engine behind economic forecasts, sports analytics, even some forms of AI. And as we get more and more data, our ability to predict things gets more powerful. Which brings us to a really important question. As we get better at predicting outcomes, how do we make sure we're using that power for helpful insights and not for unfair judgments?